Welcome to Future Doctor NEET Academy for the problem solving session in NEET Physics. Topic chosen today is from chapter 6, Electromagnetic Induction, shortly called as EMI. And today is not problem solving session, problem questionnaire session. That is, 7 questions will be spared in this section, and then next session we will solve the solution for this question. Let's move to question number 1. The magnetic flux linked with a coil in Weber is given by the equation phi equal to 5t square plus 3t plus 16. The magnitude of induced EMF in the coil at the fourth second will be dash. A option 33 volt, B option 43 volt, C option 108 volt, D option 10 volts. Let's move to question number. A circular disc of radius 0.2 meter is placed in a uniform magnetic field of induction 1 by pi Weber per meter square in such a way that axis makes an angle of 60 degree with B. Magnetic flux linked with the disc is dash. A option 0.02 Weber, B option 0.06 Weber, C option 0.08 Weber, D option 0.01 Weber. You should know the formula for magnetic flux related with the B value, R value, and all. Then you are able to find the solution for this question. Let's move to question number 3. As a result of change in the magnetic flux linked to the closed loop shown in the figure, an EMF V volt is induced in the loop. Work done in taking a charge of Q coulomb once along the loop is dash. A option QV, B option 0, C option 2QV, D option QV by 2. Here you should know the relationship between work done, magnetic flux and potential. By knowing the formula, you can derive this formula and solution. The total charge induced in a conducting loop when it is moved in a magnetic field depends on dash. A. Rate of change of magnetic flux. B. Initial magnetic flux. C. Total change in magnetic flux. D option final magnetic flux. Here that is a total charge induced. That depends upon what factor. By knowing the idea, you are able to solve this question. Let's move to question number 5. A wheel with 20 metallic spokes, each 1 meter long, is rotated with a speed of 120 rpm in a plane perpendicular to a magnetic field of 0.4 G. The induced EMF between the axle and rim of the wheel will be dash 1 G. What is G? G is a Gauss, equal to 10 power minus 4 Tesla. Option A, 2.51 into 10 power minus 4 volt. B option 2.51 into 10 power minus 5 volts. C option 4.0 into 10 power minus 4 volt. D option 2.51 volt. That is, you should know the relationship between induced EMF and then that RPM, that is the frequency range, and that B value, magnetic field B value. By knowing the formula, you will derive this solution. Let's move to question number 6. In which of the following devices eddy current is not used? A option magnetic braking in train. B option electromagnet. C option electric heater. D option induction furnace. That is eddy current, application of eddy current. By knowing that idea, you will solve this question. Let's move to last question. Eddy currents are produced when dash. Option A, metal is kept in a varying magnetic field. B option, metal is kept in steady magnetic field. C option, a circular coil is placed in a magnetic field. D option, current is passed through a circular coil. That is how eddy currents are produced. What are eddy current? What is the principle of eddy current? By knowing the idea, you are able to solve this question. Thank you, students. In next session, we will see how to solve the solution for this question.